looking at our Lawrence Compass software and how we can use Compass for designing, sizing and simulating solar pump systems. So I can see people are joining the webinar quite quickly, so I'll just start my introduction slowly while the last colleagues join. So you should see on your screen a GoToWebinar interface. If you have any questions during the webinar, please feel free to type them into the questions area. We will have a Q&A towards the end of the presentation today. So I'll run through some different sizings, do some demonstrations for you, hopefully give you some good information, and then we can pick up on any questions at the end. This is the first webinar we're doing on Compass, so we're going to keep it reasonably simple for everybody today to give everyone a good grounding. And then we have actually 2 more Compass webinars planned over the next couple of weeks. So we'll get into more complex sizing. So if you have any questions that we can't include today, maybe we'll get those into the next webinars for you. So we are recording the session today. If I'm going too quickly, then you will get a link to the recording and you'll be able to go back, look at the recording and check out any things that you've missed during today's webinar. Of course, you can also pass that webinar link on to some of your colleagues if anyone else would really benefit from the information we're giving you today. So the content we're going to go through today, we're going to talk first of all about how Compass fits into the Lawrence partner ecosystem. I want to then talk about the prerequisite information that you would need to get from a customer before we start sizing. Again, I stress already on this point, it's really important that we get good, accurate information before we start using the tools. So we'll talk a little bit about this. Then we'll do some sizing, explain the navigation of Compass and how you can use that to do different things. We'll look at how you produce reports. And then we'll look at how we can use Compass also for doing simulations of existing sites, even helping you with troubleshooting on sites that were installed some years ago. So we'll show you how you can really use Compass in all of those situations. So the first thing to talk about really is Compass is for Lawrence partners. So we have really lots of different sets of partners. We have our traditional product resellers and distributors that are selling and servicing the products in the field. But we also have partners that are educational establishments, that are NGOs, that are government bodies, who also we provide information to help them understand how solar pumping systems can be designed and also understand how solar technology can help them. So we have a wide range of partners. One thing that our partners have in common, though, is they use our infrastructure called PartnerNet to get access to information and tools. So access to Compass is gained through PartnerNet, and I'll come back to this towards the end of the presentation if you don't have Compass already and talk about how we can get that. So we have to look at where Compass fits in the bigger picture. So we have PartnerNet sitting there as the platform to access lots of information about our products and access all of the tools, all of the information that you need. The key principle is that with Lawrence product portfolio, if you learn it once, any of the tools, any of the products, this allows you to serve any system configuration from 100 watts to 100 kilowatts. So one thing we think is very important is that to make a relatively complex technology like solar pumping as simple as possible, we want to make sure that we provide products, tools, equipment, apps that work the same, exactly the same, across our whole portfolio. Again, this means if someone understands any of the products in the Lawrence portfolio, they can then serve customers from the very smallest to the very largest. So this key idea of learning once and being able to serve every opportunity using common and familiar tools is really important to us. So you can see in the design phase here, we use Compass. So we use Compass for designing. Actually, we also use Compass sometimes for troubleshooting, for reconfiguring systems, but designing is the key use of Compass. As I mentioned, installation of our products is then the same across the whole range. So if you can install the smallest one, you could also install the largest one. Same connection, same connectivity, same labeling of terminals, everything's the same. Then you can configure the product using our Pump Scanner app. We'll have a webinar on that next week. So if you're interested in that, using Pump Scanner and using our remote tools for management with Pump Manager and Global, we'll be doing a webinar next week on those two. But key information is Compass is the design tool here, and it allows you to design any system from the smallest to the largest. So let's think about doing our first sizing. And the first thing we want to do is talk to the customer and understand their needs. And I will stress this is a really important topic, because if we are starting off with bad information in the beginning, one of two things will happen. We'll either size a system incorrectly and the customer won't get the water they're expecting, or we over-specify a system and the customer ends up paying too much. And actually, if the quotation is too high, they're simply not going to buy the system. So the whole point of asking these questions, and actually the whole point of Compass, is to give the customer a really accurate solution. So something that absolutely meets their needs. And this tool that we're going to use, Compass here, is designed to give very accurate information. It's not a sales tool that over-specifies a pump and then maybe it doesn't quite deliver what we said it was, the water we said it would. The idea is this is really an engineering simulating tool that means that you can be sure when you design it, the solution will actually deliver the water it says it will. So to make sure we get off from a good starting point, we want to ask some smart questions to get good information from the customer. So the first thing we want to do is talk about water and not pumps. It's really not a good idea to start to talk about horsepowers and kilowatts early on. It's much better to talk to customers about water. And the first thing we want to do is understand what's the water going to be used for. So is it being used for livestock? Is it being used for irrigation? Is it being used for people in a community? Because that first piece of information will help us make some decisions on how we size the pump. And I'll come back to this in a few minutes. And in our discussion with the customer, we want to get three key pieces of information. The first one is the location of the pump. So where will this system be installed? The amount of water that we need to pump, and the head or the pressure requirements that the pump needs to do. So these are the three key pieces of information we need to size a solar pump. Let's look a little bit deeper at those three pieces of key data. So first one, location. Why is location important with sizing a solar pump? It's really important because the Compass software that we have here is holding all of the irradiation data, temperature data, rainfall data inside the software, and it holds models of that information, which allows us to model exactly how much solar power is available for every minute of every day of every year in a certain location. So this means we can very accurately model how much sun is there likely to be on an average beginning of May day, how much solar energy is coming. So then we can calculate how much electrical energy we can calculate, and then we can take this through the model. So location is really important. It's good to know the location. We don't have to be absolutely accurate down to the meter. We need to know which area is it in, so we can allow the software to pick the right data up. The second thing we want to know is how much water. What's the amount of water that's going to be used in this application? And if you only take one thing away from today, I want you to think always about water per day. So most of the problems with sizing solar pumps are starting to calculate from kilowatts or horsepower or litres a second or gallons per minute. The most important thing we want to know to give a good solution to a customer is how much water per day do you need? So if the customer is insisting on keeps talking about kilowatts or horsepower, please push them back to water per day. They might not know the answer, so this is quite easy for you to think about calculating. So think about how many people, ask these questions. How many people are there in the community? What's the typical person using per day in this community? Could be somewhere between 50 and 100 litres, depending on local conditions. It could be what crops are being grown. So if it's an irrigation scheme, how many hectares, how many acres, what type of crops are being grown. There's lots of data tables available on the internet for irrigation rates per crop. Could be a livestock application. So how many cows is this pump going to serve? Again, lots of data about how many litres a cow drinks per day, what type of cow. So all of this data is really available. And what you're trying to do is understand the amount of water that's really being used for the application, but in a water per day situation. And of course, the reason we want to do that is because we want to try to pump all of our water using solar power. We don't want to be installing batteries. We don't want to be installing generators unless we absolutely have to. We want to try and meet all of the water needs using solar power. The reason we do this is because it's most efficient, most cost effective, and gives the customer a long-term reliable solution. We're going to store water in an elevated tank, of course, and then we are going to use that elevated water typically for a community or for livestock to give water through the night. Obviously, if it's livestock, we can pump to a drinking trough. If it's for a village, we pump to an elevated tank, so we have water available 24 hours per day. And then the last thing we're going to do is work out our pressure requirements. So we're going to do that by doing some calculations based on what the site looks like, where the water is going to be moved from and to. So let's introduce some pumping terms. The first thing we want to think about when we're calculating this head or pressure is what's the static head or static lift. And what we're looking for is looking at the whole system, what's the lowest point that the water needs to be pumped from, and what's the highest point it needs to be pumped to. And we're only talking about the vertical distance here. So we're not talking about how long pipelines are, how far the distance between a borehole or the water source and a tank we're pumping to is. We just want to know the height. So what's the vertical distance? So in this diagram here, you can see this is a borehole. So we're saying the lowest point is going to be the pumping level, so the dynamic level after drawdown, so the lowest point you will pump from to the highest point you will pump to. And again, it could be there's a hill in between these. We want to know the highest point that the water is going to go to. So lowest point it pumps from to the highest point it pumps to gives us our static head. Again, forget the pipelines for a moment. Static head's what we're looking for here. And we will, I'll introduce this second term to you because this will come up in Compass. We also will typically allow Compass to calculate the TDH. But if we look at, you see TDH or total dynamic head, this is really the whole pressure losses and requirements within the system. So the static head, this vertical distance we just mentioned, plus any losses we have in our pipeline, friction losses in pipelines, fittings, etc., plus any output pressure that we want from the pump. So for example, if our requirement was to go into an irrigation system and we maybe need 1.5 bar of pressure to run a sprinkler, we would add on a pressure requirement here. So it would be, we would add 15 meters of static head to give us 1.5 5 bar of pressure, for instance. So by taking the static head, and then if we need to add any output pressure, we can add that. What I would typically do is let the friction losses be calculated by Compass for most simple pumping applications. If you've got a very complex situation, you might calculate your own friction losses. If it's a relatively simple one, I'll show you, we'll do that directly in Compass. So that's, I think, enough talking about introduction. Let's get down to doing some sizing. So let's do a nice simple example. We've got some good information here from talking to our customer, and we've tested this a little bit. So we've got a location in Tanzania. With the customer's very clear here, it's a small community and they want 20 cubic meters per day. The pumping level is 52 meters below ground. So we know that the water level, actually this is already the dynamic or pumping level, so 52 meters below the ground. We're going to pump water up a hill 12 meters to a tank, and the tank is 5 meters to the top. And our tank then is going to be 200 meters away from the borehole. So we've got some good information, I think, here. So we know the location, that's good. We're happy with having the location. 20 cubic meters per day. So the customer told us this. Does it make sense? Can we check this? So what questions could we ask? We could ask questions like, how many people are there in the community? And they might say, okay, it's 500 people in the community. Okay, and just do the maths in your head. Does that make sense? If we've got 500 people, that says 40 litres per person per day. Yep, that sounds quite feasible. Sounds like a sensible number. Sometimes people will get a decimal point in the wrong place, so it's just worth thinking through yourself, does it make sense? If they tell you it's 200 cubic meters per day for 10 cows, this would clearly not be right. So you just test the questions with the customer all the time. Think logically through, does this make sense or doesn't it make sense? Of course, you can go back and ask questions. I always like to ask 2 or 3 questions, even if the customer's confident about the data they're giving you. Sometimes I'll say it's a 500 meter borehole, and you think, well, actually, I know most pumps we install in that area is actually 150 meters. So maybe they got their feet and meters mixed up. So it's worth checking all the time that these questions are correct and the data's correct, or you'll end up oversizing the system. So we're happy with 20 cubic meters, and then let's take the data we have. So we have 52 meters plus 12 meters up the hill plus 5 meters to the top. That's 69 meters static head. It's 200 meters pipeline, and as we're pumping into a tank, we don't need any pressure at the end of the pipeline. So we're not going into sprinklers or irrigation system. If we're just going into a tank, we need no pressure at the end. So that's a good set of data, I think. So let's go into Compass. Good. So here's the Compass software. Compass software is installed on your PC. It's an application that runs on a PC. And after the installation, enter the license key. You get to this screen. First thing in Compass you can do is look at the settings. I do this rather slowly because I know that the screen refresh on some people's connections is quite slow. So in the settings, here it allows you to select a language. So we're supporting 5 languages here. It allows you to select your units, so you can choose obviously to use metric units, you can use US units. If you want to, you can even combine and customize your units. So if you wanted to use cubic meters or liters for flow and feet for distances, you can even combine the two. So take a look at the units there. You can combine them. And the only other thing you can do, I would say is really important, is if you want to customize the header, so this is for the reports, which we'll show you later, you can customize the header here as well. And I'll come back to this. We'll come back to this later. So set your settings, get your language at least correct, and then you're good to go. So we're going to be sizing a submersible pump. Again, if you look across pump sales for us, it's probably 90% of pump systems are submersible. We do have a big surface pump range, but submersible pumps are still around 90% of the solutions out there. So we get here our Compass main screen, and maybe it's a little bit overwhelming in the beginning, but it's really quite simple to use. The first thing we're going to do is we're going to select a location. So this is, we said we were in Tanzania, and we said that we were going to, Kinondoni. And you see that Compass then will pick up the latitude and longitude for the location. So we've got 7 degrees south, 39 degrees east. If we look at Tanzania, there's a reasonable a number of choices for locations. If your location's not on the list, if you enter latitude and longitude, that's also fine. So this will give you good data. The town names here are, sometimes you think, well, there's a small town here, but not a big town. That's because the places are based on weather centers, weather capture locations, not necessarily on the biggest towns. Good, so we have our location. The next thing we want to do is look at either our total dynamic head I mentioned. Actually, we want to do a static head and a pipeline, so I definitely want to put a pipeline in. We said we had a static head of 69 meters and a pipe length of 200 meters. And yes, we're going to use plastic pipe. And the other thing we wanted to know is the required daily output. So this is 20 cubic meters. And for completeness, the other thing I should really complete is these two factors here. So motor cable, you can see here always, when I click on one of these, it's going to give me a hint as to what we're looking for. And if we think about our 69 meter static head, so we know we had 52 meters in a borehole. Let's allow 10 meters maybe below the surface, so 62, and maybe 5 meters to the pump controller. So let's put a 70 meter motor cable in. And do we know our borehole water temperature? It's 15 degrees in this case, so we can put that in. This is going to help us choose the right pump in terms of temperature classes, so that's a good piece of information. So location's in, our pressure is in, so we're using static head plus a pipeline, and then we've got our required daily amount, so 20 cubic meters per day, and I hit calculate. So what Compass is doing, what it's sitting and thinking here, is really going through quite a complex set of mathematics. So it's looking at the location, it's looking at choosing a pump that meets the hydraulic requirements that we have. It's then going through and looking at the power available for this location from the sun, and then it's going to work back the electrical requirements for every day of the year. It's going to work this back through and then come up with some solutions for us. And actually it's giving us a few different solutions. All of these would work and give us what we need. You can see there's some slightly different pump models. The one at the top is they're sorted by a product name order, which typically implies the cheapest price. So if we sort them by name order, you could see it's actually probably technically the best pump here as well when I look at this, but you can see that they're sorting by name order. Sometimes you'll have some very different pump systems. When you get close to the largest size of one range and onto the next range, you sometimes see a good different variety of pumps. So let's look at what this is telling us. So it's telling us our cubic meters per day through the year. Obviously this location is relatively equatorial, so we're only 7 degrees south from the equator. So we see this is fairly constant output through the year, 21 to 22 cubic meters per day. And we can also see here what an average day looks like. So we can see on an average day, we get half a cubic meter at 7 o'clock, 1.5 at 8 o'clock, and then we're up to 2.5 cubic meters per hour through the day. So we can see what our water's looking like for our average month. And then here we have, if we want to look at a specific month, so we can look at maybe May looks a little bit lower. Let's have a look at what May looks like. And we can see May, yep, it starts at 8 o'clock, not at 7 o'clock. So we can see the difference. Another hint for you is if you see that there are low months in the year, you can go to the secondary axis here and you can look at rainfall or other characteristics. So again, I think this is quite logical. We see this April, May is quite low because this is rainy season. So rainy season means that there's obviously more cloud cover, which means it means that we have more cloud cover, less irradiation, less power generated from the PV modules. So that's why we see a lower amount. Again, if you think about many applications, maybe if it's the rainy season, there's less water used. So this is also fine. Good. So first view here is our output. So we see our system output. We see we have a PS2 1800 HRE pump, and we're going to put on that 1.6 kilowatts. And the configuration that we've got here is 4 times 2 LC200 modules. So 8 in total, 200 watt modules. And if I quickly look here on wiring tab, it will show me the configuration of those modules. So you can see here we have our controller, we have 4 modules in series, and we have 2 strings of 4 modules. So Compass is calculating the voltages required, calculating the power required, and showing you how to configure the modules and how many modules you would need. So very simple to see that, just going to the wiring tab. Let's jump over to, we can see here we have 6mm cable, and it's saying our pipe should be 35mm, our 200 meters of pipe. So our output is 21 cubic meters per day, and our efficiency is 13 liters per watt peak. So this is really your wire, actually end-to-end system efficiency. So it's saying for every watt peak of power, so watt peak of solar installed, you will get 13 liters of water out of this system. So this is a really good end-to-end efficiency measurement. Good. So let's click onto the system outputs. That's looking at water. You can also look at irradiation. You can look at the energy produced by the PV modules. Normally you're going to be looking at water because, of course, the customer is buying water here. They're not necessarily interested about how much energy there is in the system at this point. So I want to look now at pump characteristic. And what the pump characteristic is going to show us is whereabouts on the pump's curves are we running. So with the configuration we have to kind of pick a point in time. So let's say it's a nice sunny day with 1,000 watts and we're in Tanzania and we have an ambient temperature of 35 degrees. So what would our pump be doing at this point? So we can see that it would be running, somewhere in 70, where are we, 74 meters of head we can see we'd be consuming at that point 750 watts of power. So again, super efficient, this pumping at that point, really super efficient. And we can see here all of the voltages, speeds, pipe loss calculations are being done, see flow speeds of water. So all of the technical data we can see by looking at our pump characteristic. And we can use this pump characteristic to model lots of different things if we want to. So if we want to say, what's it going to look like first thing in the morning when there's only 200 watts, well, we could do that here and just see what the pump would do. Yeah, so at 200 watts, we would be right down here. 200 watts per square meter irradiation, we would be really way down here. So this allows you to simulate through the day what's happening. But most important thing when we're looking at our first sizing is the pump looking, does this pump have room for error? So if any of the data we got from the customer is wrong, are we going to push the pump past its head? If this blue line was here, on close to the maximum head, I might be saying, let's choose a different pump, because if the customer data is wrong, this might cause us a problem at installation. And it's always better to choose a pump that has some room for error in terms of customer data. The next tab we can look at here, of course, is also then the PV characteristic. So we can look at what does our PV generator give us with different configurations. And again, if you look at what's being done here, and this is why you really need software to do this, this is calculating out temperature losses. So it's working out for any period of the day, and it's working this out iteratively. So what's the effect of temperature in terms of losses on the PV modules? What's the effect of the losses in the pipeline? What's the effect of cable losses? And it's doing this for every single hour of the day to come up with the right pump size. This is, I would say, almost impossible to do on paper. You really need a tool to be able to do this, and you need something as sophisticated as Compass to do this accurately. So I would really encourage you always to size pumps, not guess them. The tools here, as you can see, it's relatively easy to get a sizing. I know we're going in a bit deeper here, but it's relatively easy to get a sizing and get a result. So we've gone a bit complicated there. Let's get back to this, the simple point. When we sized our system, it's chosen a system, PS1800 HRE14 with 8 PV modules. Actually, we like this. Let's produce a report from this. So I'm going to go to my report tab here. And the point of the report tab is it takes all the information we have and puts it together in like a mini project plan for the customer. So this gives us a bill of materials that we need. It allows us to create a report with lots of information in, so I can choose what I include. I would maybe like the pump data sheet to be in, maybe information about the module, and I can just hit create report. And what it does is then creates a nice PDF report of the system we just did. So we only put in 3 pieces of data, remember, location, pressure or head, and the daily requirement. And we have here then a list of equipment, what this pump's going to do, the technical information about the system characteristics in terms of the pump and the PV generator, information's in here. The wiring that we saw, so here we can see the wiring. We see a component diagram of all the components in there to help understand what's being included for a customer. Then we have a data sheet about the pump, so giving the information about this specific pump here. And then we go on to the module data sheet, etc. So this report's really quite full and is a very powerful thing to firstly demonstrate fully to the customer what they would be getting for their investment. It's also a technical assurance to say what we've designed here is what we will deliver. So it's giving assurance to the customer that the amount of water they can deliver, we're showing how much water we will deliver with this solution. If we compare this to competitors, just saying here is a 5 kilowatt pump, cost X, that's really so different from providing a system that says this will deliver you 20 cubic meters every day of the year, and here's the evidence to show you that it will do that. So very, very different proposition for the customer. So let's close that down. You see that this is all branded with Lawrence. You can very easily brand this yourself. So if I go into my settings, I can do this. Let me just show you how to do that because it's really easy. If I go into my settings, again, I'll slow down slightly. Here we're using Lawrence header. Let's change that to a custom header. And if I now can become Adrian Honey Pumps, and I can even put my own logo in. So let's put a nice honeycomb logo in there. So now when I go back to my sizing sheet, calculate using the data we had again. And now when I do a report, then I've got my reports all branded with my own details. Again, obviously you can change the address, change the your contact details, so then you can come up with a very professional report here that has everything in. So high value to your customers and increasing the value of your company using these tools. Good. So let's jump forward now, and let's assume that we have some new news from the customer. So we have our solution here. We've sized this for him. We did our 20 cubic meters, we did our 69 meters head, we did a 200 meter pipeline. Let's just assume that we got some news from the customer, and he's been talking to a friend of his in the next village, and they said, actually, you've got a really good borehole. Maybe we would like to, can we get water from your borehole? If you're installing one of these really nice Lawrence pumps, actually, can you also deliver water to our village? We can't do it yet, but maybe in 12 to 18 months, we would like to do that. So what we need to do is add another 20 cubic meters for the next village, and we need to increase our pipeline by 1,000 meters. So let's see how we quickly do that in Compass. So remember, we've got a pump here, which is our HR14H, and we've got 1.6 kilowatts. So I'm going to increase the pipe length to 1,000 meters. And what you notice is, just by doing that, Compass is immediately showing a difference. So it's showing me that I'm actually getting less water. Let me change it back for you, and you can see this happen. So if I'm on a 200 meter pipeline, you can see 7,740 cubic meters per day. If I go to a 1,000 meter pipeline, you'll see that we lose 200 cubic meters in the year. This is simply because longer pipeline means there's more losses. If I make the pipe smaller, you can see all of this works dynamically. So if you decided actually 35 meter pipeline is really expensive, let's put a 30 or even a 1 inch 25 millimeter pipeline in, you could see the effect that that would have on the system. So you can really use this to play around. So as I've now lost water, I'm down to 15 cubic meters. If I add a bit more power, can I get that back up again? Yeah, so you see Yeah, I can play around and really see how I can fine tune this system. Let's look at what we needed for this example though. So we're going to put 1,000 meters of pipeline on, and we're going to we want 40 cubic meters per day. So let's ask Compass to recalculate that based on that new information. And what Compass is telling us is actually, if you want to do that 40 cubic meters per day with a longer pipeline, we're going to need a different pump. So it's suggesting we use here a PS2 4000 now. And it's telling us that we're going to need 3.6 kilowatts, and it's configured these 7 times 2. Again, what does that mean? We can check. 7 strings, 7 modules per string, so in series, and 2 strings of 7. So it tells us how we configure our PV. And so that's a different pump, of course, with more power. So this is really good because when you put 2 villages together, this tells us the pump you would need. So what we could do is, remember the customer saying this is in 18 months time, what we could do is sell this pump, but actually we can reduce the power on it so that it only delivers 20 cubic meters per day at the moment. Let's keep taking our power down. So that's just gone too low. Yeah, so that looks pretty good. So we could give the customer a couple of options here. We could give him the first sizing that we did, which was the PS 1800 with 1.8 kilowatts, something like that, giving him 20 cubic meters. Or a second alternative would be, actually, if you really want to add the next village on, you think in 18 months, why not buy this slightly bigger pump, the PS2 4000? Again, it's the same physical size, fits in the same borehole, but it's capable of more flow later. Install this now. The price point is obviously more expensive, but not so much more expensive when you consider pulling a pump, installing a new one. It's maybe a few hundred more. Install the pump now, install it with reduced PV, and then when the next village comes online, all we need to do is add some more PV modules. And you could even do this over time. So this happens quite a lot if you think of things like irrigation schemes for fruit trees, for example. You would install a pump big enough for the fruit trees in 5 years' time. But what you would do is every year increase the amount of PV to increase the flow rate of the pump. But it's a really good idea that you install the pump for the end amount of water at the beginning. So I hope that makes a lot of sense. You're giving the customer here 2 options. Here's a solution which gives you the water you require today. If you think there's a high probability that your neighborhood community might want to join you in 12 to 18 months, as you mentioned, you could choose this pump now, but we'll install less PV on it, so less solar modules on, and then you can just add solar modules when the next community comes on. So this is a really good way of budgeting. Of course, if you don't need to pull the pump, change pipe work and things, adding PV modules, just adding solar modules on the surface is a really quite cheap and quick thing to do. So this really keeps the project nice and simple. You do the pump work once, and then you just add PV as required. So this is a good option to add to your customers. Good. So let me do a quick summary, and then we will go to some of the questions. There's lots of questions been coming in, and maybe we can run through a few examples of things that people are asking. So I want you to think that Compass here is, I know we've given it only a relatively short introduction there for you, but I think you can see just with what I was starting to do, this is really a very powerful sizing and simulation tool. And I will kind of give you an assurance from our side that this is really giving you accurate results. It's not not designed to make Lawrence pumps look better than everyone else's. Actually, if you compare it to most other people's claims, this is really giving you very real data. Yeah, we want this customers to be very happy when they choose a system, and typically we might deliver a bit more water than the tool says, so it's quite conservative. So please, if you're using this, don't think, maybe I should add a bit more power or choose a bigger pump to make sure my customer's happy. The software is going to make sure you have the right pump. So please use it as a tool, not as a, no, don't think of it as a sales tool here. Think of it as a technical configuration tool, because it's giving you the real answers. I would encourage you always to size systems. And I know if you're doing lots of installations that are similar, you might think, actually, I know which pump this is. Please check it. So please do the calculation. Sometimes Compass will flag something to you that you didn't think about. Sometimes there could be a new pump that you weren't aware of that's available that fits the situation better. There are 300 pumps here, so there's a lot of choices that it's going to pull from. So there could be a pump that you aren't aware of. Very importantly is test that customer information. So we need to make sure the information we've got is good. Ask different questions to test it. So again, as I mentioned, if someone asks for 1 million litres a day for a population of 2,000 people, that's maybe not right. So again, question it. If you find out that there's something going on, there's an industrial process, a factory that's also in the community, it might make sense. But always good to test these things to make sure that the quotation and system is not 10 times bigger than it should be. Be really careful on things like people saying, well, we have a diesel pump that's 10 horsepower or gives me 100 litres a second, and then extrapolating that by 24. Please don't do that. Calculate what's the water required per day for the community, and then you're on a good place. And really practice using Compass. So don't be scared of it. You can't break it. Use it, try some scenarios, do lots of what ifs. So say, okay, what if I increase the pipeline? What if I want to use a different wire size? What if the customer wants more water next year? What if the calculation of head, I don't really trust this guy, he's not very good at measuring. What happens if it's 20 meters wrong? So you can test all these things using Compass and come up with different solutions. And the last thing I would say is you can see here that quite often you can think a bit further forward. So you can ask a customer about his requirements going forward. If he sees the population growing over time, if he sees that maybe he might acquire some more fields to irrigate, if the plan is to increase the amount of livestock on this land, ask those questions and maybe give 2 options to the customer. Here's what you asked for, but actually here's another option that gives you the chance to irrigate twice as much water, but add the PV on later. So install the right size pump now, add PV later. And you might be surprised how well received this is by customers. Firstly, they often see that you're really thinking about their solution for them, so they see good value in this. And the second thing is they say, actually, I didn't think about that, but that's a really good thing to do. And if the price is not crazily different, they might really take the more flexible option sometimes. So don't assume always that customers are looking only for the cheapest price. Of course, everyone's looking for a fair and good price, but sometimes people have really a lot of vision about what they would like to do in the future. And if you can address that rather than just saying, I've got the cheapest price, that adds a lot of value to the consultancy you're doing for them, the work you're doing for them. Good. The last point I will say is if you don't have Compass at the moment, there are a couple of things you can do. So firstly, I'm assuming that as you're on the webinar, 95% of you are our existing partners working with us. If you don't have a PartnerNet account, then please ask the boss or whoever administers the Lawrence relationship within your organization, because they will be able to send you an invite to join PartnerNet, where you can download Compass and you get your own license key. So please don't try to share license keys, because this will cause problems for everybody. You'll start to get blocking and locking and accounts not working. So please get your own account. This is free software. There's no license charges available to our partners. So yeah, firstly, ask the boss, whoever looks after the account. If you don't have that or can't find it, please send an email through to the marketing team. Let us know your name and email address, which country you're in, and which organization you belong to. If you aren't already a Lawrence partner, then also please drop us a note to say why you need the software. So if you're in education, if you're an NGO or a governmental group, then let us know so we can add you onto the system. Good. So thank you for that. Let's do some questions and answers now. So I've got quite a lot of questions in already, and let's see if we can answer some of these, if not fully, at least in part. So we have several questions going back earlier to locations on Compass. So let's have a look at locations. So we have, obviously, in our locations here, every country. And if we pick any country, we will then have a list of towns, cities, villages, locations within the country. If something's not listed, don't worry too much. Please pick up the longitude and latitude of the location, and that will be enough. So here, if it's not really Kampala, but close by Kampala, and we know it's actually 1 degree north and 33 east, we can just put this in, and it might pick up the nearest town. If not, it will just might be blank. This is still okay. Compass has the data for each location. So as long as we have in the latitude, longitude, that's okay. You don't need the town name. If there are missing locations, we can add them to the database, but to be honest, this is only from this only doesn't add more accuracy. So using latitude and longitude is fine if you don't have the place on the list. The next question that's in here is on dirt loss. What is this dirt loss here? So the dirt loss is a figure that you can set, and this is the losses that you would have from having dust and dirt on the PV modules on the solar panels in normal use. So we set this at 5% as a kind of fairly good average planning number. If you are installing in a location which is extremely dusty, and you know it's really dusty, with no rainfall, so no chance to clean modules, then you might want to increase that. But I would say 5% is a fairly good number. So this is the losses that you'll see on power production from the PV modules. This is calculated right through. So I mentioned dirt losses are calculated, cable losses are calculated, temperature losses are calculated, the friction losses dynamically are calculated based on flow for every minute of the day. So all of these things are dynamically calculated to really come up with a very accurate flow and pressure calculation for the pump system. Yeah, a question about when we did the reporting, what does project mean here? So let me go to the report tab here. I've got a few things we can do when we customize the header of our report. Here I could type a project name in. So if I want to give the project a name for the report, I can. So I can village expansion project. So I can give this a name here. And I can also put the customer in. So what I can do is actually have, I can either call this over here, I can add customers that I use, that I work with regularly. So this is actually a quote for Joe's Pumps. You know, I can add customers in there. So if I have a regular customer that I quote for, you can add it in to save typing in. So I have my project and customer name included. So again, this is about how you can quickly do sizing, create this professional report to give to the customer. There's a couple of technical pumping questions which I'm not going to cover today. So we will cover those. There's 2 or 3 very technical ones here which we'll cover in later webinars. So in terms of absolute locations of pumps and things, we'll cover that later. Yeah, so there's actually 3 different questions which I'll try and group together here, which talks about how can we look at maximum flow rates, for instance. So of course, if we look at the real world, then many boreholes actually have a safe yield or a performance that they're capable of doing. So a borehole will often have should have a pumping report. So this is a report that was produced when it was first drilled. And again, for older borehouses, maybe have to be redone every few years, where there's a pump test done. The pump test will work out what the safe yield of the borehole is. So the borehole might be good for 10 cubic meters per hour sustained pumping. So this is sometimes a constraint that we have to think about in our sizing. So what we would be able to do is set a flow rate limit. And to do this, I'm going to have to go to my settings, and I can show additional inputs. So if I show this additional inputs, this is going to give me what we call expert mode, but a bit more flexibility on what we can do. So we can change some things on tilt and angles here, plus we can also then set a flow rate limit. So if we were working with a borehole that has a flow rate limit of 4 cubic meters per hour, for instance, I'm now in expert mode, so it's really asking me for a pipe type. So let me put in a plastic pipe, and I would calculate. So again, now we have a different, now we have set up some different parameters, like a limit, then it's going to maybe choose a slightly different pump. So yeah, it's chosen as a slightly different pump and more PV to allow a longer pumping day to still give us, our 40 cubic meters, but it's having to do this in a different way because we've set 40 cubic meters per day, but only 4 cubic meters per hour from a borehole. So where we have borehole yield limits, we can use the tool still for doing these. Good. Sorry, maybe it wasn't so clear. So let me go back to the 5% dirt loss topic. So let's so the 5% dirt loss, let me try and explain again. This is talking about how much. It's kind of a bit of a arbitrary figure. So 5% is what I would say is normal amount of dirt that sits on a PV module. So the solar panel itself is going to be sitting exposed, of course. It's going to get dust collecting on it. If you have rain, they get cleaned. If you have a weekly or monthly cleaning regime, they will stay very clean. If they're left to get dirty, then there will be, the dirt on it acts a bit like wearing sunglasses. It reduces the amount of light hitting the solar panel and reduces the amount of electricity then it generates. So the more dirt that sits on top of the PV module, the more dust. It's kind of like the darker the sunglasses, the less less power is generated. So if we have very, very dirty, dusty conditions, we might want to go up to 10 or even 15% losses. If we know that the panels in this area typically stay quite clean because it's not a dusty environment or there is fairly regular rain, then 5% is a good number to use. So this is all about a little bit of local understanding. And of course, the purpose of it is what the system will do is calculate how much power is required even with that dirt. So it will make sure that if you've asked for 20 cubic meters per day, you will get that, even if you're saying, but I've got 20% dirt losses, I think, because I know this area is really super dusty. So this allows you to still calculate an accurate water output, even though you know that the modules will be really dirty for 3 weeks of the month. Just going back through the questions, exact. Okay, there's some questions about batteries here. As I mentioned earlier, we are typically sizing with no batteries. If you look at pump power, sizing battery systems for pumps gets really expensive quite quickly. Of course, you can run anything on batteries. What we're really trying to do in 99% of the time is pump water during daytime and store it in an elevated tank, so we store both water and energy. But where that's not possible, it's often maybe more attractive to use a generator rather than batteries. Batteries sizing for pumps tends to get quite big and expensive very quickly. Yeah, let's have a quick look at surface pumps. I know we're a bit over time, but if you have the time, we can take a quick look at surface pump sizing as well. Good. So here we can size a surface pump, and you'll see that the sizing of a surface pump is very similar. Let's take some options off here. So we choose a location. Let's pick somewhere randomly in Uganda. And we are getting a slightly different diagram here, of course. A surface pump has got a suction side to the pump and a discharge or pressure side. So as a submersible pump is submerged, you don't typically talk about suction side, you only talk about the discharge or pressure side. So let's look at the information we're going to need. So there's a missing box here, which is blank, which is altitude. Let's assume that our place in Uganda here is at 200 meters altitude. If I click on here for dynamic pressure head, it's asking me what's the dynamic pressure head, so the vertical distance, yeah, exactly the same as we had for the submersible pump, but here we're going from the inlet to the pump, the height of the inlet of the pump, to the highest point we're going to pump in the system. So again, 30 meters is good. And we can also put a pipeline on here. So let's say we have a 200 meter pipeline on the discharge side. Now we're going to move down to look at the suction side. So we are in a suction head situation. So water's coming from this river into the pump. And we can say that we have 2 meters vertical distance between the top of the water and the inlet of the pump. Again, we can choose our pipe types here. and how much water do we need per day. Say we need 100 cubic meters. And we can hit calculate. And so what Compass is now going to do is going to look at surface pumps that meet that requirement. It's going to choose a pump that meets the suction side requirement. So it's going to choose a pump that will meet the suction side requirements. If you're getting errors, so if I put this at 10 meters, for instance, it's going to say you can't do that. So what Compass is going to do is always find you a pump that fits. So in this case, suction head of 10 meters is impossible, so I get no result. So it's not going to let you do anything or size anything that you can't do. The other thing you can do in the sizing here is you can have a positive inlet head. So this is if we have a pump that's lower than the surface water level, we can set a positive inlet head again here. So this is very similar to sizing submersibles. Obviously, only difference is we have the suction side calculation. So you can do both. You can even do swimming pool pumps if this is of interesting for you. There's lots of questions here coming up. So I've got 7 or 8 different questions about is there a pump to do X or Y or Z? So can what pumps are available? Actually, I'm going to click on this pump system tab here, and this is going to show you all the pumps that are available. Yeah, so we have all of our pumps in here. Actually, we have data about every pump. So if we look at down to the largest pumps, we can see here we have pumps that really will do. Now this pump here is doing 767 cubic meters per hour. So very large pumps, right down to very small pumps. So really a whole range of pumps available in here, from some very high head ones. So we can move up to pumps like this, very high head pumps, through to, this will be a nice high head pump for you. So 300 meters, right through to very high flow pumps. So really a whole range. Good. And on our PV generator here, we can also define, if we want to, we can define lots of different module types. So this is the PV modules. Today you can see I've just been using 3 that I selected for, and Compass would only size using those 3. If you want to add your own PV modules, you can add them, no problem. So you can add them in here. So this Solartech module here, I could just select that, and then it would use that particular module for doing sizing. So you can add custom modules in here very easily. Right, let's look at the more questions. So some questions about efficiency. Yeah, some questions about maximum power point tracking. So again, there's some technical questions here which I probably won't cover now. Of course, our systems all have maximum power point tracking in them. This is one of the key reasons why I'd always recommend you size systems using Compass, because what Compass is always going to do is find you the most efficient and best solution. So rather than trying to do any calculations yourself of motor power times X factor times inefficiency for MPPT, forget all of this, all of the things that you've tried to do before. Use the software, because the software will do this 10 times more accurately than you can calculate it. I think given 3 days, I could probably do a sizing that takes the software 3 seconds to calculate. It would really take 3 days of paper and Excel to come up with something that is as accurate as this is doing, simply because it's an iterative process and computers are good at that and people aren't so good. Okay, so we're running a little bit over time. I think I've got through most of the examples there. Most of the questions I think I've covered in what I've talked about. I would encourage you to, again, get comfortable with Compass. It's very easy to use. There are some tips and tricks that we'll kind of give you over the next couple of webinars, but if you have a chance, I would encourage you to install it, play around, and then join the next webinars where we can talk about how to do some more complex things, how we can really use this tool for different scenarios as well. So thanks for joining us today. There will be an email coming to you this time tomorrow with a link to the recording. So if there's anything you missed, anything you want to run over, you can do that tomorrow from the recording. So thanks again, and hope to catch you on the next webinar. Goodbye.